Okay, we're going to review about chapter 6, exponential function. We are going over the topics, how to calculate the average rate of change of a function over an interval. Let's see some examples. So I want just to skim through this thing, guys. Okay, but let me put this.
Jay rides in a boat from his home to his friend's home in a neighboring state. The graph of the function d of t equals 30 times the absolute value of the quantity t minus 1 and 5/10 shows the distance of the boat in miles from the state line at t hours. What is the rate of change over the interval t is greater than or equal to 2 and less than or equal to 2 and 5/10? What does it mean in terms of the situation?
Now, the essential question for this problem or for this kind of skill is going to be, what are the key features of the graph of the absolute value function? What do you see? How do you observe the graph? What patterns do you see? Make sense and preserve. The rate of change is a different constant value for each section of the graph. How does this relate to the situation? Let's see what the solution is telling us about this graph. We use the slope formula to determine the rate of change from t equal to 2 and t equal to 2.5. Now, use the points 2 and 15. As you see here, 2 and 15, these are the coordinates we're going to use. And 2.5 and 30. 2.5, as you see here, x t 2.5 and d, it's 30. Now, you already know the formula for slope, which is change over d, change in y over change in x. So m is equal to y2 minus 2y1 over x2 minus x1. As you see here, 30 minus 15, 2.5, which is x2 minus 2, which is x1, and we get 30. The rate of change over this interval is 30. The rate of change represents the speed of the boat in miles per hour. Since the rate of change is positive, J's distance from the border is increasing. The boat is traveling at 30 miles per hour away from the border. Now, I'm just giving one example for each one so you'll know what you have to do. Find the nth term of geometric sequence. Finding the nth term of geometric sequence. These are the skills we have been learning in this chapter. How are geometric sequences related to exponential function? Keep in mind this question during the review. Study tip. The common ratio is the fixed number used to find terms in a geometric sequence. The common ratio cannot be 0. As you see, very important, the common ratio cannot be 0. Now, if you see here,
is the sequence an arithmetic or a geometric sequence? Part A, 3, 2, 4/3, 8/9, 16/27, and so on.
Let's see what the solution is telling us. If we do a geometric sequence, so a geometric sequence is a number sequence in which each term after the first term is found by multiplying the previous term by a common ratio. Look for a common difference or a common ratio between consecutive terms. Now, in these consecutive terms, before we go to the next step, take a look. Do you see any common difference? Take a look. Stop the video and see it yourself first. If you don't see any common difference, look for a common ratio between consecutive terms. 2 divided by 3, 4/3 divided by 2, etc., etc. Let's see now what's next. There is no common difference. So 2 minus 3 is equal to -1, and 4/3 minus 2 is equal to -2/3. So there is no common difference. but it's going to be the common ratio, which is 2 divided by 3, 2/3, 4 over 3 divided by 2 is 2/3, etc. As you see, here is a common ratio, so this is going to be a geometric sequence. The sequence does not have a common difference, but has a common ratio of 2/3, so it is geometric sequence. Let's go to the next skill. I'm just going briefly and talking a little bit fast, so the video is not going to be long. Okay, you can go to Virtual Nerd to see for how to find the nth term in geometric sequence. But for exponential function, identify the effect on the graph replacing fx by fx plus k. Let's see the vertical translation. Okay. How do changes in an exponential function relate to translation of its graph? Let me read it in Spanish.
¿Cómo afecta el valor de k a la gráfica de f de x es igual a 2 a la x potencia más k?
How does the value of k affect the graph of f of x equals 2 to the power of x plus k?
Okay, again, as I have previously mentioned on the other videos, compare the graph of gx is equal to 2 to the power of x plus 3 and j of x is equal to 2 to the power of x minus 3 to the graph of fx is equal to 2 to the power of x. Let's see now. The function gx is equal to 2 to the power of x plus 3. What happened to the graph compared to the parental function, which is fx is equal to 2 to the power of x, and function jx is equal to 2 to the power of x minus 3. Now we're going to see the vertical translation. What happened when we add? What happened when k is positive and what happened when k is negative? How is the graph shifting or translating? Let's see now. The graph of fx, 2 to the power of x, as you see here, so this is the translation. Translation is 3 units up. As you see here, it's 3 units up. Let's see now when it's negative. What happened when the function is negative? What happened when the k is negative number? What happened now? Translation 3 units down. It shifts down 3 units. As you see here the y intersection here is 1. So it's going 1, 2, 3. Translation is going to be 3 units down for the second. Always compare to the parental function, which is function of x is equal to 2 to the power of x. Okay, let's see next one. I'm just trying briefly to show you guys. Okay, exponential model. A function can be exponential. Let's see now. And this is an example from the previous videos too, but is good for review. Essential question: what kinds of situation can be modeled with exponential growth or exponential decay functions? And we're going to use the structure, the order of operation when entering your numbers on a calculator. Very important, guys, when you use your graphing calculator, if the omission of parentheses, how it changed your answers. So you have to pay close attention how to put parentheses, how to put the exact equation in order.
Kimberly's family invested in a certificate of deposit for her when she was born. The interest is compounded quarterly. Part A. What is the value of the CD at the end of 5 years?
All right, let me put it in Spanish so students that feel more comfortable in Spanish language, they can hear the question.
La familia de Kimberly invirtió en un certificado de depósito, CD, para ella cuando nació. El interés es compuesto trimestral. A. ¿Cuál será el valor del CD al término de 5 años?
Okay, now as you see here, the certificate of deposit amount deposited is 3,000. Annual interest is 8% and interest compounded quarterly. So this is interest is going to be compounded quarterly. Let's see now. Use the compound interest formula. Guys, you can use the scaffolding, you can use the worksheets that I have posted in Google Classroom for references. And here is the formula for compounded interest. It's A is equal to P times 1 plus R over N to the power of N times T. Now, let's break down the variables one by one so you understand what you're talking about. Now, 3,000 is the principal amount. So the 3,000 is the principal amount. The rate of interest is 8%. 8%, turning the 8%, converting 8% to a decimal number is 0.08 over 4, which is calculated quarterly. That means 4 times per year. Divide by 4 to the power of 4, which is quarterly, 4 times t. Now we're going to see how many years. T represents the years. Okay, now here 3,000 times 1 plus, when we divide 0.08 by 4, it's 0.02 to the power of 4 times t. Now, in this case, they're asking us the years. What is the value of the CDs at the end of 5 years? Now, we do have this variable given, 5 years. So 4 times 5. You plug these numbers in a calculator, guys, and you will figure out that at the end of the 5 years, the value of CD will be $4,457.84. Okay. I'm just giving one example for each problem. Okay. Again, you'll find you can go back to the assignments that I have assigned, but I would like to go with written explicit formula for geometric sequence. Let's see this one. The formula for geometric sequence. Now, as we said before, the essential question for that was how are geometric sequence related to exponential function? And it says here,
what is the 10th term in the sequence 8, 12, 18, 27, 40, and 5/10, and so on?
And remember, we did plenty of class work on this skill. How do we figure out the nth term? Explicit formula, A sub n is equal to A sub 1 times R to the power of n minus 1. So this is the general formula, where A sub n is the nth term, A sub n is the first term, and R is the common ratio, as we did in the previous problem, finding the common ratio for the geometric sequence. The first term is 8. The common ratio is 3 over 2. You figure out by dividing the numbers. And a tenth, so a tenth, because we are looking for 10th term. So a sub 10 is equal to 8 times 3 over 2 to the power of 9. And the number is 307 we're going to round to that to 55. Yeah, 55. The 10th term in the sequence is 307.55 rounded to the nearest hundredth. Let's go to the next one. Let's go to the exponential decays. Exponential function can be exponential. Okay, let's see. Exponential functions. Oh, we did this. We're just trying to figure out some of the problems to review. Let's see here now the geometric cursive decay. I just wanted to figure out some decay formulas. Okay, and you see the virtual nerd for what is exponential growth. Vertical translation. Okay, let's see horizontal translation. We saw the vertical translation. Let's see the horizontal translation now. For the horizontal translation, again, the essential question: how do changes in an exponential function relate to translation of its graph? And common errors again. Remember that the graph is translated, right, when h is positive, and left when h is negative. When h is positive, and left when h is negative. This is the opposite of the effect of subtraction of positive of a number line. Now, let's see.
Compare the graph of g of x equals 2 to the power of the quantity x minus h with the graph of f of x equals 2 to the power of x when h is greater than 0. What effect does h have on the graph of g?
Let's hear it in Spanish.
Compara la gráfica de g de x es igual a 2 a la x potencia menos h con la gráfica de f de x es igual a 2 a la x potencia, cuando h es mayor que 0. ¿Qué efecto tiene h en la gráfica de g?
All right, let's talk about the solution of this. What's going to happen in horizontal translation? In this case, h is equal to 5. So h, in this case h, this h here is equal to 5. And compare the graph of gx is equal to 2 to the power x minus 5 to the graph of f of x is equal to 2 to the power of x. So always this is the parental function, function of f of x is equal to 2 to the power of x. When h, so when this h here is greater than 0, the graph is translated h units to the right. So it's translated h units to the right. As you see here, this red here, orange, sorry. It's translated h units to the right. The graph of g is translated of f to the right by 5 units. Now, use the slider to explore the effect of different values of h. Let's see now. So, h is equal to 5. Let's see how, I'm going to move this mouse here, and you're going to see how this is going to be affected, okay? As you see here, let me stop here, as 3. Do you see how it's narrowing down now? As farther I go to the 5, 6, farther down to the right. You see, almost approaching 0, but it never touches. As it shrinks, h becomes smaller. It becomes closer to the parental function, which is the blue one. The parental function is this one. Right? Oh, no. Okay, fx is equal to 2 to the power of x. Now you see how it moves. Okay, now, let's see next one. When
Compare the graph of j of x equals 2 to the power of the quantity x minus h with the graph of f of x equals 2 to the power of x when h is less than 0. What effect does h have on the graph of j?
Compara la gráfica de j de x es igual a 2 a la x potencia menos h con la gráfica de f de x es igual a 2 a la x potencia, cuando h es menor que 0. ¿Qué efecto tiene h en la gráfica de j?
Okay, let's see the solution. What effect does h have on the graph? Let's see what's happening to the graph now when h is negative. Now, let's h is equal to -3 compared to the graph of 2 to the jx is equal to 2 to the power of x plus 3 to the graph of fx is equal to 2 to the power of x. When h is less than 0, the graph is translated h unit to the left. The graph of j, so the graph of j is translation of the f to the right, to the left by 3 unit. Now, let's use the slider to see the different values of h. As you see here, when it approaches 0, the function approaches the parental function, which is 2 to the power of x. But as we get smaller and smaller, as we approach the numbers, smaller numbers, -7, -8, etc., it goes farther to the left of the graph. So it goes farther to the left. But as you see, closer to the 0, you see how's the difference between the numbers, between 0 and negative, infinity. We go as farther we go to the left. By the numbers, the smaller we get the numbers, the larger distance will be between the parental function and the new function. Okay, now let's move to, I would like to explain something when I assign work for you guys. When I assign work on Math Excel for school. For example, as I assign work for different levels. Let's see this. Let me show you how to use the skills, how to use the help. As you see here, you see the questions, and if you're finding difficulty to solve, you have question help here on your right of your computer, right? And you press question help. You do have different choices for this. Help me solve this. I'm going to guide you through this so you know what I'm talking about. So for next time, you will know how to help, how to ask for help in this website. Let me see here now. Find the value of k in the graph of the right. So if I have no clue about this, right? It says to compare the graphs. This original graph with the new one. Define points that both graphs that have the same x value. Now you need help. Let's continue. For the help, you continue. And it says the y-intercept of fx is equal to 5 to the power of x is what? Now you can see. Now you can see here. So this is the function, the red one, right? So the red graph represents the function fx is equal to 5 to the power of x. Now, what do you see? The y-intercept in this case is 1. So just press 1 here, whatever you observe, right? Okay. Let's see. Check the answer. It is 1. Good. Now it says more help. You continue for more help. The y-intercept of gx is equal to 5 to the power of x plus k is what? And again, you take a look the new graph. What is the as you see here, the dark one, the graph here, this is, now you can count 1, 2, 3, right? So how many numbers it shifts? It starts here, right? 1, 2. It says 2, so k should be 2. You see, I'm just counting the numbers. Check the answer. Oh. Okay, this is not correct. Okay. The y-intercept of gx is type an integer as decimal. Oh, we have to, okay, check the answer. Or we have to type, okay, you see, when you make a mistake, you check it again. K, what is k in this case? What is k? Okay, k is 1, 2, 3. So it's 3. My mistake, sorry, y-intercept. So it's 3. Let's see, check the answer. We make mistakes, everybody makes mistakes. Fantastic. Okay, so you see how you help yourself how to figure out. And as you do this, you keep notes. And we close this and you go and finish your work that you're assigned. So you see what other options you have here. You do have videos. This is, I sent the picture about this, but please use this information. These questions help for now, since you're doing the remote learning. It is going to be helpful for you guys. Video. When you have the video, it's a virtual nerd that explains everything. You have seen this before. I'm not going to spend time.
What does the value of a do?
I'm not going to spend time on this, okay? So you already know. What else? And you have a textbook. In textbook, it gives you guys the problems, how to model and discuss, and you have with the solutions. Again, you have an opportunity to review. Okay, let me go next. What next? You find the glossary. The glossary, when you go to glossary, as you see here, we are an exponential function. So we're looking for E, the letter E. And you skim through here. What are you looking? Exponential function. Let's go in exponential function. This is very good visual. You will see the exponential function. It gives you the definition.
A function that repeatedly multiplies an initial amount by the same positive number. You can model all exponential functions using y equals a times b to the x power, where a is a non-zero constant, b is greater than 0, and b is not equal to 1.
As you see here, the graph demonstrates the exponential growth. The exponential growth with the blue one and the orange one with exponential decay. Guys, I hope this information is going to be helpful to you to review for the test. And we're just doing our best. Both you and I are doing the best to make a successful learning through remote learning.